this is from lesson 3. This is from lesson 3, and it was question 4, and we're going to work on a precipitate question. So precipitate questions always assume we're going to get a precipitate when we hit the KSP. So what we want to do is find out what ions are in the solution that could cause a precipitate, and it tells us that we're interested in manganese sulfide. So I know that manganese sulfide, when it breaks down in solution, would form manganese and sulfide. Manganese has a charge of +2, sulfide has a charge of -2. This is an X to X to X ratio. My KSP will be concentration of the manganese +2 ion times the concentration of the sulfide -2 ion. Now, I don't need to substitute the X's into the bracket. I would if all of the manganese and all of the sulfide came from manganese sulfide. But the thing is they're telling us the manganese is actually coming from another source. They're telling us the manganese is coming from somewhere else. They say we've got manganese nitrate. And from our solubility rules, we know that any compound that contains a nitrate or an acetate is very soluble. And so this breaks down completely. So we'll use a one-way arrow to show that it's not going to be in equilibrium. It'll break down completely to form manganese ions and 2 of the nitrate ions. So if this is 0.1 molar concentration and all of it breaks apart, this is 0.1 molar and this is 0.2 molar. Now I don't really care about the nitrate, but I do care about the manganese. Because in this solution with these 2 salts mixed together, okay, the concentration of manganese is 0.1 molar. It'll be 0.1 plus the X that we get from manganese sulfide, technically. But I can tell from this very tiny KSP that that value for X is super small. So even if we calculated it out and added it together, okay, and solved this using a quadratic equation, this still value would have worked out to 0.1000000 something. It would have like 7 zeros, and significant digits would have rounded that out. Okay, so in effect, because this manganese nitrate was so soluble, it provided all of the manganese. Now, we know the KSP. We know the KSP value was given as 1.4 times 10 to the minus 15. And if the manganese value is 0.1, we can now solve for the concentration of that sulfide ion. So we'll go 1.4 times 10 to the minus 15. We'll divide it by that value of 0.1. And I get a value of 1.4 times 10 to the power of minus 14. And that will be equal to the concentration of the sulfide ion. At that point, we have hit our maximum solubility. Because this much manganese that we have here, and this much sulfide, which we calculated here, hit the KSP, and that's our maximum value. So at that point, if we put even 1 crystal more of manganese sulfide in, boom, we get a precipitate.